Welcome back to class. I hope things have been going well while staying in quarantine. I know that one thing that has been tough for me is keeping up with friends and staying productive. I've been trying to write every day and send what I write to my friends for peer review. I can't do schoolwork all of the time, can I? Anyway, that's just something that I've been doing to try and stay productive. Um, I've been trying to keep these lessons under 15 minutes so that you have plenty of time to research and look at things that I mentioned in class that you may want to look further in. I'm always taking questions through email, and I'm happy to answer anything that you have. Um, well, without further ado, let's get started on the lab. All right. I hope you were able to finish the lab tomorrow, from yesterday, I mean, because you need that today. Just to remind you, the point of this lab is to show that matter is not lost or gained when going through state changes. I'll show you my lab here. Here's my cup of ice still. It's melted a little bit, but that doesn't change the experiment at all. Here's my cup. As you can look at, the water's frozen. It's ice now. Solids are almost always colder or at a lower temperature than the same substance is in a liquid or gas form. Water is the most universal substance that we see in each of the three basic states of matter, but there's another that I found too. It's carbon dioxide. We don't see it as much. We breathe it out, of course, but we can't see it. But you can freeze carbon dioxide to make dry ice. I'll send a video out with my email later that has some dry ice experiments in it. They're really cool. So look forward to that. They put that through a solid, liquid, and gas state as well. All right. Now, if you have a scale, that's gonna come in handy here. But if you don't, well, we can improvise. The materials that you can use will vary. It just depends on what you have around the house that will work. Let's see. So we're going to make a balance. Has same purpose, but a little different. Let's see. And if you have a scale already, then we're all going to try to make a balance here. I want to see what you guys can come up with. I'm really excited about what you can do. All right. So, you need two objects when making a scale. You need a long flat object and a fulcrum. I'll explain here in a minute. So, for long flat object, it needs to be balanced. I used a wooden spoon. It's almost completely balanced. A good test is to stick your finger out and then set it in the middle, and then once you find the balance, then you have the point of equilibrium right here. That's where it won't fall one way or the other. Now, your finger in this case is the fulcrum. The fulcrum is where a lever can pivot or balance. This balance is considered a lever because it can go both ways. See? Alright. Next, what I use for my fulcrum is this flashlight. I just set it on the ground here and then set my flat object on it. The best fulcrum is something that is pointy at the top, or at least tapers. If it's flat and like my measuring cup here, that's not as good of a fulcrum because there's a lot of surface area that the flat object can rest on. So my flashlight works best in this case because there's just a little bit of surface that the flat object can rest on. Now, next, well, you have that. Well, let's see. Get these things first, then pause the video, and we'll move on to the next part. Alright, now that you have your materials together again, from the previous lab, then, well, okay, as a reminder, here we are. You need the cup, you need an empty cup without anything in it. It has to be about the same as the cup you used earlier. See, these are almost completely identical in shape and weight. Now, you'll need to fill this up, your measuring cup up, with exactly 1 cup of water, just like we used yesterday. I'll do that. Alright. And then you'll fill the empty cup with water. There we go. Alright. Now, here's the fun part. We have our, I'll move this. We have our scale here, our balance, I mean. There, we got that. Now, I'm going to take my frozen ice here, and then my cup of water. Now we're going to test to see if 1 cup of water, when it's frozen, if it gets heavier, implying that more mass was gained when it was frozen. So, moment of truth, I'm going to show you with mine, and then I'm going to hope that you do this yourself as well. Here, let me move that. Due to the nature of this spoon, it's a little curved, so I have to, as long as I put them both on the ends, it should be just right, as long as I get them to balance on the spoon. It's a little curved, of course, so, alright. And there. Nope. Here, just a second. Sorry about that. Took a second to balance things. I had too much water in my cup. I didn't measure it right. Measuring it is very important here. If you don't have it exactly 1 cup on both sides, it's not going to work. As you can see, once it's been measured correctly, it works. Been perfect equilibrium. No more weight on one side than the other. Alright, then take a picture of what you use, and take a picture of your balance at equilibrium state. Then we'll send it in an email. I'll cover that in the next section. Then get your paper ready that you used yesterday, and we will start again in a minute. Alright, good job with the lab. I forgot to mention earlier, if you have a scale, then record the weights of both, of the cup of frozen water and then the cup of water, and that will give you a more surefire example. Since not everyone has a scale at their house, I don't have a scale at my house, for instance, then I came up with an alternative that we could have used. Alright, for the last part, I would like to start a lab report. We'll do this in 2 parts, and we'll finish it tomorrow. But all scientists use lab reports to document what they learned from doing their lab, and so that other scientists can read it, learn from it, and compare results. Lab experiments are supposed to be replicable or able to be repeated or done again. If other scientists can't repeat an experiment, then it's no good. The original experiment is considered null or void or not able to be used. So for yours, I will send a template It will tell you what you need to do each day, but you'll be listing the materials that you used. The hold on. You'll have your materials. You will have write down a place for your observations that you made, and of course the original hypothesis of what you think was going to happen before this experiment and what you were trying to test. Anyway, I'll send that all in an email. Great job, everyone. Um, this experiment has been pretty fun for me too. And be sure to email me. I know all of you can email me now because we did a lesson on that yesterday. And without further ado, I'll see you later.